Welcome to the 5th episode of Cartesi's Tiny Podcast, a pocket-sized podcast that's here to try and explore the road to mass adoption. We'll be talking with Web3 adventurers and blockchain wizards in bite-sized 15-minute episodes. This time I'm talking with Carsten Munk, board director and mad scientist at Cartesi. He's been busy with rickrolling sequencers, putting Linux in ZK, but this next 15 minutes we will be talking about the how and why of putting Cartesi on Bitcoin. Carsten, you joined Cartesi last July as a board member, but you've been around for a while. Tell us, where are you from? What have you been doing?
Yeah, I actually looked yesterday and I saw that my first kind of like message or like noticing Cartesi was in like March 2021, where I told to my friend that this is completely crazy, but extremely cool. And my friend in response says, yeah, they look like they sacrificed a lot of goats for this one, for basically being able to run Linux onto a blockchain. And it's still completely crazy, right? But it's something that actually works. And I've been around in the community using the software in the company that I work with, which is called CP, where I'm Chief Technology Officer. And I also then joined, as I said, that here in July, I joined as a board member in the Cartesi Foundation, kind of like helping and to push from the point of view of what do Cartesi customers actually want, and kind of sharing that expertise. But I'm originally from Denmark. I'm a computer scientist, and I have been doing things like mobile Linux before in my time. So yeah, that's pretty much where I'm from and what I do.
All right, then let's talk about what we're doing now. Last October, Bitcoin launched BitVM. You've been tinkering with that. Tell us why was now the time to do that?
Yeah, so like as you know, like Bitcoin is more like a decentralized ecosystem. So there was one particular innovator, Robin Linus from ZeroSync, that put out a paper called BitVM, where basically they outline a way to do verifiable computation of Bitcoin. And probably most people don't know this, but like Bitcoin and its virtual machine as in Bitcoin script is very, very limited. It is so limited because Satoshi Nakamoto basically disabled a lot of the kind of like the useful things that the Bitcoin script can do, like let's say putting two byte strings together and a couple of other things. And because of a panic, because he thought that basically everybody could crash the network, and it was quite early in Bitcoin, and it basically meant that it was a horrible experience to actually go ahead and try to implement anything reasonable on Bitcoin. And what the BitVM people did was essentially find a way out of those restrictions, so you can start putting, let's say, more general purpose computation onto Bitcoin and do it over multiple transactions, because Bitcoin doesn't have state, like for example Ethereum does. They don't have state on kind of like amount of money you can spend from a particular address, for example. And this is kind of like where we then started looking at it and saying that well, we have this Cartesi hackathon coming up. What's the most ridiculous project that we're never ever going to get permission to do on company time? We chose to let's put Cartesi on Bitcoin.
Do you know why the BitVM people decided to do that now? Because we have alternatives.
We have alternatives, but at the same time, there's still quite a big, let's say, Bitcoin community out there. Like, in terms of, let's say, economic security, because of the hash rates and so on, like Bitcoin is still the biggest, right? Like there's nobody that has successfully mounted a real attack against Bitcoin in that way. And there's still interest in it. It's solid, it works, it's well supported. But the problem is that especially now, Bitcoin is getting to the point where, and this is my understanding of it, that basically the transaction fees and the amount of, let's say, Bitcoin that the miners get out from mining transactions getting quite low. So if they need to keep their security budgets up for the network, they actually do need actual traffic on the network and use of it. And this is naturally something where many people are interested because there's a lot of vested economic interest in it. And I don't know exactly why now that BitVM is coming out, but they basically had a breakthrough in something they call bit commitments, where it's possible to kind of like share a piece of information across multiple transactions, and combined with kind of like the understanding of how things like optimistic rollups work in Bitcoin, it attracted a lot of attention. Like the Telegram group is like 1,000 people plus at the moment, like really coherent, sane discussions. And I think it basically inspires a lot of potential on doing actual verifiable things on Bitcoin.
All right, then back to the hackathon. You chose to spend that week on the craziest thing you could do on BitVM.
Yes.
Tell us.
As we kind of like started diving in, because what BitVM enables essentially a little bit like making these Boolean circuits, like AND, OR, XOR, and so on, not. And first we think, okay, let's try to see if we can kind of like maybe handwrite them or something like that. But that's boring. It takes a lot of time. It's really not that nice to do. Then we found that there was a 5-year-old academic software that allows us to take this programs made in the C language and turn them into Boolean circuits, which can be used in BitVM in this particular case. And then we essentially took what the Cartesi has, which is called the microarchitecture, which is like the smallest possible instruction set, and started trying to put that into BitVM. And we actually got something working that passed test cases and so on. There's naturally a couple of practical difficulties about the way we've been doing things, but kind of like it was interesting to kind of like take something that was considered impossible just, let's say, 2 months ago, and actually start doing it on Bitcoin. And recently, after the hackathon, the BitVM people have been able to do what's called Merkle proof verifications, which basically mean you can do things like having computation with, let's say, external memory, essentially, or like big lookup tables, those kind of things. Lookup tables useful because then you can kind of like make particular operations that are not possible in this scripting language. So it is moving very fast, this space at the moment.
All right. What were the biggest problems you ran into while building it?
I think the tooling was quite, let's say, weak initially. We found out the hard way that let's say, many stuff like hashing is very, very expensive. Because like for our virtual machine, we have to do like 61 hashings of two values together to kind of prove the entire address space of our virtual machine. It was completely academic software, like it was not very well documented, and we kind of like first later on found out how to kind of like make good circuits of things. But right now, like the main challenge of, let's say, Cartesi on Bitcoin is that right now BitVM is like between a single prover and a single verifier. And I think that there's some things to kind of be sorted out in the model for that, because it's like you can't make this whole roll-up experience just yet where kind of like you can get money in and out of it and anyone can kind of like come in and participate. So there's still many kind of like issues to kind of like sort out.
What would it be useful for other than getting more traffic on the Bitcoin network?
It's a little bit like when it comes to, let's say, verifiable computing in Bitcoin. I mean, this is something that basically they're doing things that haven't been possible before. Sometimes it feels a little bit, it's like putting, let's say, Doom on a electronic pregnancy test to do this kind of things. But it might be that by enabling these things, there might be somebody out there that suddenly has an idea that basically means that they can now go out and actually implement it. And if we then combine BitVM with Cartesi, then it becomes much easier for people to express this process in a way, because they can develop it just like they develop for a normal Linux machine, right? And if that power comes in, it might be that there's use cases sitting on top of Bitcoin, essentially because like it is like beyond nation state security level. That might be quite interesting. I mean, like let's imagine that somebody takes on a project like, for example, Kleros, and does basically nation state level arbitration system, and can easily write this up in even something like JavaScript. It could actually have real use in the world, because nobody can deny that there's security in Bitcoin. I don't think any state denies this at this point. While you can always argue with Ethereum proof of stake that may be like very big whales and so on, but like when it comes to hash power, it's very, let's say, democratic.
You briefly mentioned Doom. I believe I heard in one of your presentations in Istanbul that you actually put Doom using Cartesi on BitVM, right?
Well, once you get the bottom microarchitecture working on Cartesi, basically you can put everything else on top, right? So I personally foresee that, yes, we will be able to potentially, let's say, compete about high scores on Doom, for example, in the same way we're doing it right now. For example, I think it's the World Arcade, for example, and basically get paid out Bitcoin for it. I mean, it's an interesting use case. So I mean, first we need to put Linux on Bitcoin, which is already quite big, and then we can put Doom on Bitcoin, and then we're going to make everybody sick by putting PHP on Bitcoin.
What are the problems that are still remaining? What needs to be solved?
I think that it's kind of like in the architecture of doing BitVM. I've had some very good conversations with the team behind, where they understand the value of RISC-V and test cases and so on. So I think as they're kind of like right now what they're doing is like a toy virtual machine that kind of like shows the concept and it works. And then I think basically the next step for anybody is to implement a RISC-V virtual machine on top of it, where Cartesi fits very nicely in because it's open source, it's a public good. It is well documented, it's well tested, and it can run essentially a full profile on top of it. So I think that's kind of like how things go at the moment. But there's still some kind of like hurdles they're figuring out. But this is the good thing. It's 1,000 minds that are contributing in one way or the other to kind of solving this problem on Bitcoin. And I was having a discussion on Telegram the other day with somebody from the Cartesi community, and like it's something we're actively working on. It's like something we're experimenting with, because there might be something interesting, just like we're experimenting with things like, let's say, Espresso Sequencer or Agile, because we sense that Cartesi should be the virtual machine for most purposes out there.
That's actually a good little bridge to the last question, which would be for me, doing marketing at Cartesi. How can we be spreading the word about this? How are we going to get more and more people enthusiastic, at least, and involved in the second place?
I think that once the big hurdles are out of this, and it becomes something where it's easy to take a Cartesi machine and put it on top of something like Bitcoin, and it's easy, we actually open up to an entire new community, not just, let's say, the Ethereum community, but also the Bitcoin community. And it's a different audience for sure. And I think from that point of view, it enables us to speak about Cartesi not just as something for Ethereum. It might be something that works correctly even on something like Filecoin or in Agile as a kind of like a Linux coprocessor, but something where we really drive home that this is how a real world computer looks like.
Fingers crossed, I wanted to say, but it's also due to hard work, so maybe better if I said, let's get to work.
Yeah.
Thanks for your time and your explanation, and we're going to be following these developments closely.
Yeah.
Next week, I will be talking with Elisa, one of the winners from our hackathon we did with Intelli in Brazil. We will be talking about what she's built and the Brazilian blockchain landscape in general. See you then and there.